Good morning, everyone, and happy Valentine's Day. Today, we look over some challenges that you might face when you do predictive analytics. Some of them might be very relevant to your final project. Okay, just keep in mind, these are the coming dues. So assignment 6, which is a significant assignment, assignment 8, and so there's just 1 minute difference as well. Is 12 today? Today? Okay, I changed it to. Okay. So I think if you might remember first day, I said you can have one late assignment. So, but just keep in mind some assignment like assignment 6 might be challenging and needs more time. But again, you can have one late assignment. But maybe it's better to keep it later. Maybe you would have some exams or some midterms from other professors. So, but we have also in a few days, we have first project deliverable. Any other questions about the assignments? Okay, so last week we started talking about predictive analytics. We talk about some general standards, which generally speaking, all of them almost follow similar steps, but for different applications. We had our first NIME experience, which you'll be able to do some prediction using a data set. Yeah, I'm using a different PowerPoint software, not Microsoft, because my current laptop is with the help desk. So it's the reason some of the pages might be a little different from you. So for assignment 6, you can do even a predictive analytics if you want. You don't have to, but you can have something like maybe you can adopt the previous workflow and divide your data in 2 sections and do even a predictive analytics, but you don't have to. Even Tableau is enough. But just in case if you want, this is a way that you can go with that. Yes, some of you taking pictures, but I think the PowerPoint files over Moodle could be better than mine. But okay, so we will have some discussions about the challenges that you might face in predictive analytics. In case you want to read more, please read chapter 4.2 to 4.5. So it gives you some solid foundations about the concepts that we are going to follow. So let's talk about bias in algorithms. This is one of the hottest. It gets very hot recently, especially. Do you guys remember this picture? Do you know where is that? Where is that? And have you been there? Oh, have you been during this like Black Lives Matter movement? Okay. So it was. I mean, people were protesting for different things. One of them was bias among people of colors, and they think police is not fair for everyone. So this is, but similar to this concept, you might face something in algorithms. So let's say if your police is not diverse enough, or they haven't trained how to deal with such situations, they may not do in the professional and proper way. Similarly, if you train a model with the bad data, or if you don't train well, your predictive model might behave in a very bad way and might be biased toward different genders and different people of color. So let's say, let's talk about gender. Let's say we are going to see a video about gender bias in predictive analytics. So let's say you have a trained data set. In your train set, almost all the observation is about males or men, So it's more likely that your model is trained well for men, not females, because maybe you have less number of observations to train your model. Let's look at this famous example. It's about Apple credit card. How many of you have Apple credit cards? At least one, two? Huh? Oh, you got rejected? Yeah, if you are immigrants, sometimes credit cards might reject your application. So there's another type of secure credit cards that usually you never get rejected.
We have only joint assets.
So the story is do you guys know Steve Wozniak? Yeah, he's a co-founder of Apple. Now he's just enjoying with his life. He's a billionaire, he's enjoying his life right now. He's doing some proper causes. So he's married to a lady, and both of them applied for a credit card. So they're so biased in the amount of credit line is dedicated to these two persons. And this is the story of is a one of the most famous stories about bias model. So let's say millions of people apply for credit card. They might have to do two things. First, let a human decide about the credit line, which is not that much economical. So they should hire so many people to look over so many documents. Another way, they develop a predictive model to predict the amount of credit line that they should assign to a certain person, to different person. This is the case. So let's look at the video.
Only joint assets, joint income. We don't have joint bank accounts, joint credit cards. We just really don't have anything separate. We don't have any prenuptial agreements or anything like that. It's all the same. The money comes in, it gets deposited by wire in a bank account for both of us. It doesn't even go through my hands or hers. So how could we wind up different? I always think in terms of assets and income, and it's the same for both of us, and that should determine your credit worthiness. But that's not how it turned out.
I mean, my credit limit was 10% of what my husband's was. I just kind of laughed because I was like, it was so low I could barely buy a phone or a plane ticket, and I buy all of his plane tickets. So I was like, we're going to have to use some other card, even though that Apple card's my favorite card to use.
We love the card for a lot of reasons. Very simple to use. We don't have to have 5 different cards for different types of purchases and complicate our lives. But it's really a good card for its benefits. It was just sort of a surprise. Why would we get different credit limits? Maybe some accident happened.
Basically, I had called into Goldman Sachs like a couple times, and they told me that they could reevaluate it in 6 months. But when I called, they contacted me after this stuff aired, and I talked to a gentleman today who said that they are reanalyzing my credit score. So I have a feeling it'll be based off of both of our numbers rather than some number from I don't know how many years ago, maybe before we were married.
So I don't really get totally upset about it. Like I said, I didn't come out when Janet got her low credit limit months ago. I didn't try to espouse anything, you know. It was just a post by somebody else, by Mr. Hansen, and I said, oh, we've got a similar situation. I was adding it sort of as a little humorous, little point adding on, but it was sort of an amplification.
So this is one of the things I will look at your project. So I want to see if you investigate that there could be some potential bias in your models. Yeah, I teach you some of them. Sometimes you can Google and find other ways that you can have less bias in your models. You do your best. Sometimes you cannot improve the bias, but at least I want to see in your project you look at bias. And maybe you try to improve. If there is not that much of bias, that's fine. So just mention that it was what you did, and based on your analysis, maybe you had a bias, you try to do different things. You may or may not improve it. Okay, so on top of that, Also, we're going to look over two examples of machine learning algorithm. One of them is artificial neural network. The other one just k-means clustering. So artificial neural network is a sample supervised learning model, and k-means clustering is an example of unsupervised learning algorithm. So any questions so far about bias and other things? Okay, so there's an issue that you might face is outliers. So there's different causes for outliers, but these are the issues that might affect the precision of your models. So basically, you just deviate your model from the truth. This is one example. So is a jumping team, and the coach recorded their performance in different days. As you see, almost everyone had an improvement except for Sam. So sometimes it's good to investigate. So outliers sometimes provides good information, sometimes has a reason. But as you see, when you do the mean of the team with Sam, it seems the team performance is decreasing. But if you exclude Sam, there's a significant increase in the performance of this sport team. So maybe here it's better just exclude Sam and just ask him what happened. Maybe he was just drunk last night, or so he couldn't jump well. So it is so the mean is not a good summary of information for the whole of the team. So there is certain methods that you can use for finding outliers. So one of them is some statistical algorithms that basically do the box plots, and anything operates some certain standard deviation from the mean, or basically indicating of an outlier. In machine learning algorithms, usually there is some measures, or if I'm talking about Python, it might be some packages that let you know what are your outliers. So look at these two examples. So in both of them, we have an outlier, and we try to make a regression line. If you, in some situation, the outlier is basically very close to the regression line, so it doesn't affect the slope of the line. But if it's far from the regression line, so it could deviate the slope significantly. So regression line is one of the methods that you can do for prediction, and just one outlier could let you to have a very bad regression line, and it could cause. So if you use it for future prediction, it might cause a significant error for your model. So these are that much bad. Cook's d-test is another statistical measure that you can use for finding outliers, but they are not usually. Sometimes they are not bad. Actually, they are. Sometimes they provide some very useful information, like fraud detection. So if you end up being in a financial company or a bank, so you don't your fraud situation or fraud transactions are outliers, but you want to find them and you want to investigate them. So medication, public health. So except for some pandemics, so usually outliers basically just tell you there is some health situation somewhere that you need to pay attention. On top of that, sometimes you might get just typos. Typos could be for, like here, look at the size column. So it could be just, it could be categorical typo, or look at satisfaction 03 column. So it could be even in the numerical situation. So if you, maybe you run some modules and just tell you so for observation. So for one of the observations, you have an outliers, then basically you can do two things. Maybe you try to fix it. So maybe you can reach to some manual documentation and you can see, yeah, it might be 5 and you can fix it. Another one, you can just exclude that observation. One more advanced method is just make it empty. So just delete the cell and then impute with a mean or median. The base case scenario, we try to avoid dropping observations or columns or variables because we don't want to lose information. So it's better not to drop. The best way is finding the real number or the true number there. And less proper way is just impute. And again, it's better just avoid dropping observations. Box plot. So in case you need to just review some of your statistical manuscript, or we can just Google it, how use box plot to identify outliers. Again, sometimes you want to focus on them, sometimes you just want to exclude them. Is more you see such a missing item more likely in the questionnaires. So sometimes some people are not interested to answer your questions. Maybe you just exclude those observations. Or sometimes you have a question that people are not that much interested to answer. Maybe it's related to private information. In those cases, maybe it's better to just drop the row or drop the column, which represent to a variable. These are some reasons that you may have column empty or observation empty. So people may not be at home. They just disconnect the call in the middle. So you might have some responses for some of your questions and they get bored. And sometimes they just discontinue the conversation. So if you're for your project, if you want to do a survey, so it's better to just minimize number of questions, especially in Clark. I see sometimes they send me some surveys of like 60 questions, 70 questions. It just takes forever to answer them. In those cases, it's very common to see so many unknown or empty cells. One way people, again, I'm not sure if you use it for this course, but sometimes for the surveys, people pay or just give a gift to people to answer the questions. Sometimes it might happen. So you need to, but I think the best way is having smart questions, not too much and not too boring. So usually there's 2 types of missing values. One could be completely at random, so there is no pattern and no certain reasons. So for these cases, we try to impute. So for whom who never did imputations, so let's say for a column of data, I just have one empty cell. If I want to impute with mean, I find the mean of the column and just put into the empty cells. Both in Python and KNIME, there is modules that help you to do it easily. Or you can use median of column to fill out the empty cells. So this is usually the approach for completely random. Sometimes there is an association or some certain or hidden reasons for why you have so many empty for some certain column. Could be like, look at this example, respondents in service occupation less likely to report income. Maybe, or might be some reason, let's say you ask about people's weight. So if they are, maybe if they are too heavy, they don't feel good to answer the questions. In such cases, maybe it's better to just don't use such questions, because there's some certain pattern between X or independent variable and dependent variable. Another one, not at random. So respondent with high income less likely to report income. So again, if you find some associations which or you are pretty sure there's a reason for not answering some certain questions, it's much better to just avoid them. I think talk about them. Okay, so again, when you have too many empty cells, just try to have these questions like about why there is so many empty. Maybe there is a pattern, or if those, like the information is that much important or not. Let's say if I have 200 columns or 200 variables for a certain predictive model, and maybe in some of them I have so many empty, and they don't bring too much of good information for me. Maybe I can just exclude those columns. You don't have to always impute. You impute for those observations that you suspect that they bring good information for you. Again, there is 3 general approaches for handling emptiness in your data set. One is just deletion, which we try to avoid it, unless they are under these 2 categories. They are not, if they are missing at random or not at random. So for the last 2 conditions, maybe just delete them. The second one, the statistical imputation, so like mean, median, and in such cases, they are much faster and more intuitive. The last one is multiple imputation. So basically, you use different methods for imputations. Maybe one time you impute with mean, another one with median. Or in a more complex way, maybe you can train some models so you predict what could be in the empty cells. So this is another way of imputation. So you can even train a predictive model for imputation. You can average them down and basically predict what could be in those empty cells. So keep in mind, imputation should not bring information for you. The reason we do imputation, we don't want to lose some variables or some observations. But when you fill out an empty cell, they shouldn't bring new information to your model. This is one of the examples why we don't want to drop observations. So looking at here, I just have 3 male as a gender, and if I just drop every row that have empty cells or missing values, my model mostly trained over females. So maybe if I want to prediction for the male, my model could be biased. In this situation, it's much better to just do imputation and fill out those empty cells if you want to avoid bias in your model. So Again, imputation, if it's a single one, a statistical one, is much faster. If you delete, because you reduce your data set, you have a faster model, but again, we don't want to do that. Sometimes you want to do just case-by-case comparison or something like t-test. So you want to basically, you want to do comparison over 2 columns of your data. In those cases, maybe you can do deletion because you just compare case by case. This is, which is basically, we don't have it for your project. So your project is not such a case. But again, in some certain application, more specifically in statistics, you can do deletion for the case, for when you want to do case-by-case comparisons. This is one example. Maybe 95% of students talk about the nationality or ethnicity. 70% talk about the family income. So let's just change the example. So let's say in one case I have 5% emptiness and the one 75. If you just drop the observations, maybe you end up losing something between 25 to 30% of your data. So let's talk about this. This figure talks about the multiple imputation process. So each line represents one method. One could be again mean, median. Another one could be just prediction. So you predict those empty cells. Then you end up having maybe five different values for those empty cells. You have a pool of imputations. Maybe you look for the majority vote, or you just average them down and do your final estimation. For your project, just one method of imputation is enough. You don't have to do several methods for imputation. Sometimes maybe you don't have to. Maybe you have just a very clean data set and you don't have to do imputation. That's totally fine too. Okay, let's have a little review of statistics and again talk about why we use machine learning algorithm in comparison with statistical models. Okay, so most of the statistical models are developed over normal data. So your normal, so look at the symmetric shape. So if you, let's say if you want to regression or let's say if you want to do basically pairwise comparison, basically most of the statistical model, your data needs to follow normal distribution. In machine learning, you don't have to, so you relax that condition. So look at the next two figures. One of them is negatively skewed to the left. So I put a shish kebab because it's just, they have a skewer. So a skewed to the left means the pointy part is to the left side. So, and same for the skewed to the right. So machine learning cancel those statistical limiter. They just relax a statistical constraints, one of them having normal distribution. So also we have kurtosis. So if the pointy part in the upside, you have some kurtosis that again you may not use some statistical model for such a case. Having said that, even for prediction, people like to have a statistical model for two reasons. One of them, they are transparent. And usually they are, you can basically look at under hood of the model and just provide some statistical proof. So there is some measures that you can convert your non-normal data set to the normal data set. One of them is transformation. So if you look at here, so my data is skewed to the right. Again, so you got the point. So your data is skewed to one direction. If you instead of using x, maybe if you use natural logarithm of x, your data would be less skewed and maybe more looks like a normal distribution. So let's say for your project, you want to do a logistic regression and your accuracy end up having very bad. Maybe your data doesn't follow a normal distribution. You have to transform your data in the normal shape. Any questions so far? So by the way, for some sessions, we invite some speakers, and there is two reasons. One helps you for the job market and see your potential, and maybe to see if you're interested to work in some certain occupations. Other one, you learn how to have a more productive presentation and how to present. But those people usually have very good skills in presenting some certain topics. So we have one. And we are talking about other people's, but for the next Monday, so I post one of our best guests on previous guests, and you can just watch the video. You don't basically the class next Monday is online. You see the video. I will be on campus. If you don't have to watch at 10 a.m. So if you have questions during your class time, you can come and stop by my office, and if you have questions, you can just let me know, and we work with that. So for next session on Monday, we have a recorded guest speaker. Please watch that. So his name is Efrad, and he's in the healthcare analytics. He used to be, he has a business degree from Clark, and he's working around here. So maybe you can find him through LinkedIn and connect him, and maybe asking if there's some opening in his company. And I think he was, I forgot his name, but his country, but I think he was from, there's a country in the east of India. Maybe Bangladesh, yeah. I think so. I think he's from somewhere very close to India. So we already talked about one bias, which is a bias for different ethnicity or different category of your data. Another one, bias in prediction. So the other one is more traditional. Sometimes when people talk about bias, usually they talk about accuracy. But again, it's not totally foreign from the previous bias that we talked. So bias just means difference from what you perceive or what you predict from the actual value. Okay, let's look at this figure. Graph A is the actual data. And let's say graph B, C, and D are your predicted value. So from graph B, C, and D, which one we have? Which one we don't have any bias? So if you look at the mean, so mean of graph A is 85. So when you do some certain model in graph B, still the mean is 85, but it's still like your data is skewed to the right. Graph C and D also, the mean is 85, but you have some certain skewed, you see your data is skewed. So although in all of them, you end up saying that maybe your mean is 85, but Yeah, you can see T has no bias, and you have the highest precision because they're very close to 85. T has some bias, and also P could have some bias, but at the end, it seems A and C are the closest one for the estimating the mean of 85 for a population. Okay, let's talk about one important thing in most of the predictive analytics project, which is variable importance. Sometimes people call it sensitivity analysis. This is different from sensitivity of prediction. So more likely, I think the best application is healthcare analytics. Let's say you have some models that try to predict patient survival after surgery. And let's say your model has accuracy of 99% in predicting someone's length of survival after a surgery. But my people might say, so what? So, okay, you predict survival for 99%, so what? So now let me tell you another application. Let's say I train a model to predict Bitcoin price in the next day, and I have accuracy of 90%. You can relate in the second case. So in second case, for you, the accuracy prediction is important because maybe you make a buy or sell decision. For the previous one, so what? So you predict someone's survival with 99%. People ask you, so what's the point of that? Do you want telling a patient, okay, you might die in like 2 weeks? So in those situations, we more interested to look over variable importance. We want to say which variables are important to survival of a patient, or more specifically to length of survival. Let's say your mother said, okay, I can predict accuracy of their survival length with 99%. Also, my mother says maybe their weight, some certain medications, BMI, and a smoking pattern are very important variables in prediction. So if a doctor, when doctor look at your model, would tell patient, okay, if you reduce your weight, maybe if you cut smoking or drop smoking, or use this medication, you improve your chance of survival. So doctors can use your models. They look at the importance of variable, and they can use it for helping patients to improve the length of survival. In those cases, reporting the variable importance is much more important than accuracy of your model. So accuracy would say you have a good model, but maybe you cannot use it that much for healthcare. While if you say, okay, my model is reliable because I have high accuracy, on top of that, these are the important variables in prediction. So now doctor can use it for helping their patient. Some of the variables could be intuitive, but at least you provide some objective measures. So maybe everybody knows that if people use BMI, they could have a better chance of survival, but now you have an objective measure to talk about, also objective proof. If you might remember previous time, we talked about Tableau. In Tableau, you provide some subjective proof or subjective discussion, but now you can have some objective measures. Can anyone tell me another example which you more look over importance of predictive variables? Data what? Yeah, that's the good thing. So you might remember, I think last 2 years, sometimes people said, okay, if you take some certain medication, one of them, even Trump said that. What was that? It was, huh? Yeah, I think Trump said about some certain medication that he believed that it would improve the survival. Remdesivir. Okay, so maybe you can do two things. Maybe they look at the look at the data of patient who use that, and say, and maybe they can have a descriptive or visualization and say, look, people who took this could survive longer, or they can basically get cured much faster and with a higher chance. On top of that, maybe they can use a predictive model to talk about their chance of survival. Another one could be, let's not talk about healthcare, maybe if a student can pass or fail. So maybe you end up using a model can predict students basically success in a course with, let's say, 95% accuracy. Okay, so what? So you look at a student in the second way and said, okay, based on my model, you failed. So, you know, it doesn't look that much good. Instead, you can say, okay, so my model says, based on previous semester, maybe if you even do some exercises, maybe if you go to consulting services, you study more, submit your assignment before the due date, you pass the course. So this is another, it could be another application. So again, for some application, we look at the accuracy. For some of them, accuracy just provides some validity or reliability for your model, but we more look over the importance of predictive variables. Any questions? Again, I provide a model, but you know that now you can just, you can Google, maybe I show it in one of the workflows, but just for your project, maybe you can just Google how to find importance of variables for a model, and you find the module and use it. And then you can talk about importance of predictive variables. Okay, let's talk about neural network. So, have you ever worked with a neural network before? So, have you ever worked with the regression? Okay. So, basically in the regression, you have some inputs, you have an objective, you have a function, maybe, there is no, you don't have any choice. So, okay, excellent. Plus x2 well, everything up to maybe 8100, or let's call it an xn equal y, right? This is a regression. So you have some inputs, it multiplied to some coefficient, and you get the output. In regression, there is a mathematical proof behind of it, which is really complicated. I used to teach it. It takes 1 pages of like mathematical proof. In neural network, we have something similar, but there is no basically there is no math behind of that. So we do some multiplication through different nodes, and just we call it neural network. But let's see how it works. So it comes from the biological neural networks. So you look at these two different green cells. You have synapses and dendrites. So the informations of, let's say when your eye sees some picture, so the information comes through dendrite and synapse. It goes to soma, and through axon, it just transfers to the next neural cell, to the next dendrite or axons, and just it goes. So these cells are from your eye to your brain. and look over the dendrites and synapses. So each dendrites and synapses are like this. There is some coefficient that multiply to your information. So x1 to xn could be some the pixels that your eye see, multiplied to some coefficient through synapses. And in summa, first summa, you get this y. Again, this y transfer to the next dendrites, and just so each time you see several multiplications to your information. Look at here. So in this figure, so x1 to xn are inputs. W1 to Wn are those A1 to AN. These are coefficients. They multiply to the inputs, transfer to Y. So within that yellow cell, there is another function, which people call it activation function. So activation function just say your output could be anything from Y1 to Yn. So if you use neural network for Titanic data set, X1 to Xn could be, one of them could be their gender, their ticket style, maybe their origin. W1 to Wn could be some coefficients. And in yellow cell, you just have two outputs. One is they die or survive. But how it works? So I told you that for regression, there's a mathematical proof behind of it. But in neural network, your computer just search for, first it just put some random weights, then try to change weights using some certain algorithms, and just try to find the best weights that at the end, so you have less amount of error. So basically, your computer just search for actual or true weights and just assign some weights. So if you ask me why W1 is one number, W2 or W2 are different numbers, I don't have any proof for that. I just said my computer search for the proper weights. This is the output of my computer search. But if you ask me in one regression line, why we have those coefficients, I can just write one page of nerd proof of Einstein style mathematical proof and say, okay, this is the proper coefficient because of this proof. It's similar for other machine learning algorithms. So in all of the machine learning algorithms, we have some certain search, which your computer search for some certain coefficients, and then tell you I found these values. It just gives me good accuracy. So let's just use those rates. Any questions? So neural network has so many applications. If look at this figure, I have 3 layers: input layers, output layer. So output in Titanic could be either die or survive. And I just have one middle layer. People call it artificial neural network. So if in the middle here, I have just one layer. Usually they call it hidden layer because it's between input and output. If you have multiple hidden layers in the middle, they call it deep neural network. So usually if your input data is images, for example, you want to look at, maybe people use it for autonomous driving. So the input is some pictures or camera of car. So usually people use deep neural network because usually deep neural network provides high accuracy when your input data is images. Look at the Y1, Y2, and Y3. So you see that it's something, maybe it's very simplistic, but it looks like something like regression. So it just, you have some inputs that multiplies to some coefficients. and gives you the final answer over a neural network. If you go to a PhD level, in PhD, people talk about, let me go back here. So look at the Y, so Y circle. So the technical term for that Y circle here is activation function. I used to have a classmate, he started PhD when he was 63. So his PhD was about how to design the best activation function. And he has a good amount of, he just graduated. I think he started his occupation when he was 67. So when you go to PhD level, so you more go under hood of algorithms, and maybe you find a better search algorithm, or maybe you find the best activation function. But for master level, you don't have to exactly understand what is going on with the search algorithm that finds the best weights, or how to find the best activation function. You just drag and drop module from 9, and maybe you just use neural network. So these are different, general architectures: feed-forward, recurrent, associative memory, probabilistic, self-organizing, feature maps, hop-filled network, so on and so forth. Basically, these names just comes from different applications or different search methods. But the overall structure is just you have some inputs. You have either one or multiple hidden layers, and you have a one output layer. The only thing that you might do for your projects, if you want to use neural network, maybe you change the number of hidden layers. Instead of 1, maybe you put 3. Sometimes you have some options in terms of which activation function or yellow circle is better, which again, you just do by trying and error and try to find the best combinations for your neural network to have highest accuracy. For your project, I need to see that you look over, you did you spent good amount of time on data preparation, maybe to check missingness, outliers, bias. And if you don't have none of them, that's okay, but at least I want to see you look over those things. Maybe, I'm not sure, I'm trying to find some data set that you may not even face bias. Let's say you want to predict crop for some, you want to predict crop yield, and your data is not in different categories. So there is some cases you may not even face bias, but it's still just say that in your report say, okay, I did my study, I look at the variables. There is no way that I can just investigate bias, because it doesn't make sense to have bias. Or maybe you do your own effort, and even you cannot improve the bias. That's fine too, but at least you try to do that. Then for accuracy, so let's say you use regression, you use neural network, you use different algorithms. At least I want to see you use 3 different approaches to have the highest accuracy. You try to improve, maybe you cannot. That's totally fine too. Yeah, these are different applications of artificial neural network. Again, artificial neural network just means you just have one hidden layer. So if you have more than that, you have deep learning. So classification, regression, clustering, even for association. So there's a wide variety of applications that you can employ artificial neural network. So looking at this figure, can you say here, do you think here we have deep learning or we have artificial neural network? The shape is a little weird. The answer is ANN, artificial neural network, but They may not be a biblical definition, but usually, which is the more common, if you have one hidden layer, we call it artificial neural network. Here, it said we have 2 layers, and still they call it ANN, but again, that should be totally fine. So for your project, here they put for ANN, but still for any project you can do that. So you should exclude one part for testing, because we don't for your project usually don't have the future data. Let's say you just randomly put 20% somewhere as a future data, and for the remaining, maybe you can just do train validation test, or you do cross validation. Cross validation is better because you have multiple validation set and training set, and when you report your accuracy, if the accuracy is almost the same for all the folds, it's just saying that you have a more reliable model that you can trust for future use. So these are some general disadvantages of ANN. First of all, this is a black box model, which just means you don't have any mathematical proof. Sometimes we have too many variables. It takes a lot of time because your model should search for all the combination of weights, and sometimes it cannot merge to some weights that brings high accuracy. It could be very lengthy. It might take forever, but this is actually a complex model for computers, because if you remember some probability before, finding different combination of weights, even sometimes you play with different number of hidden layers, so it might take a lot of time. So based on the definition that I posted here, Titanic data set, is it a supervised learning project or unsupervised? Who said unsupervised? Why? Okay, any other answer? Who said supervised? Why? Yeah, actually, both of them could be true. Let's say if you want to predict survival of a passenger, so you have a dependent variable that you want to predict. So this is a supervised learning. But let's say you don't want to do that. Maybe you want to just find passengers that have a similar characteristics. So you look over similarity of passengers. So in that case, and you don't want to just look at the ticket or gender, you want to consider everything. So in those cases, you do clustering, which is unsupervised learning. But more traditionally, usually Titanic is for supervised learning, because they already provide a column that shows who survived, who didn't survive. I think there is a question. Yeah, one of your friends says supervised. Unsupervised learning has one good application of segmentations. Basically, I think the best application is marketing. So you want to target different groups of people based on their similarities. So you can call it segmentation. And let's say if you want to use one variable, which in Tableau, you cannot use multiple variables. Maybe you look at, if you remember the bank customer example that we did in the class. So we look at different geographical regions. So one variable. Maybe we look at gender, one variable. Supervised learning helps you to just consider multiple variables and define, let's say in the banking, maybe you have the customer that are the closest characteristics to each other. So then maybe you can run different campaigns. So again, so could you relate to that? So, and sometimes segmentation is hard to imagine because our brain doesn't, it's very hard to consider several characteristics in our brain and find, let's say, four different groups of customers that they are very similar to each other with 10 different characteristics. We look over some examples. This segmentation or clustering makes more sense, but just keep in mind, this is the general definition. So let's look at this figure, how K-means clustering works. So here, I have just two variables. One of them is X, another is Y. Maybe in your data set, X could be income, and Y could be years of education. Okay. So anyway, here I have two variables. I want to find people based on similarities. So if you look at here, first, I want to understand how many clusters I want, or how many groups of people I want to just take out that have the maximum similarities based on that two variables. First, it's how your model works. So it first pick 5 random points, because I said I want to find 5 categories. If I wanted 3 categories, I end up having 3 dots. So those dots are selected randomly, similar to neural network, just select randomly. And then it assigns the closest dots to those centroids. So in the second one, you see that I have pink dots because they're closest to the upper left point. I have greens, and green just means closest dots based on that based on my X and Y to that centroid. And same for others. In the next step, it look over those pink, let's say pink dots, and it finds their actual centroid. So let me show you my laser. Okay, so first, look at this stuff. So you just select it randomly, and I identify the closest point to this random central. Your pink. This green is the closest to this one. This yellow closest to this one. Blue means these points are more closer to this centroid than this focus. In the last step, you look over just peaks and find this actual centroid, which is the middle. For the greens, instead of that one over there, you just find the closest one. Oh, sorry, the actual centroid. And same for this, same for this, same for this point. Then it just goes to the basically first step. Then instead now I have 5 different centroids. Let's reassign the points to the closest centroid. Then it assigns, then we find the actual centroid. Then we assign again and again and again until it sees that the centroid doesn't move that much. So we say, okay, I found 5 actual centroids, and also I assign the closest points to them. So here, let's say it's the last step, and I just repeat this several times. Now I have the output of my model would be 1 Y. In that Y, you have 1 to 5. They'll just say that which category or your data belongs to. One thing is Outliers, again, the goal is not just for you to be able to see all the details. You can do your own Googling, but this is the general steps. So you take away from 10 minutes clustering and also neural network. all of them works based on searches. So there's different search methods that your computer adopt to find the best solution. It may or may not be correct. Most of the time, you get a good result, so the reason we're still using them. Again, in all of them, it just works based on search methods. If you want to understand those search methods or more about these algorithms, maybe you need to take some computer science courses that talks about all of the details. Any questions? Yeah, so next class, we have another hands-on experiences. I start having some supervised and unsupervised project. And you can see it might be some ambiguous concept that I reviewed today, but when you do some hands-on experiences, it would make much easier and much more understandable when you do the actual work. Next class, again, you see a 9 workflow, and we start using them. Some modules might be relevant to your project, some of them may not. Still, you can also Google and find other workflows and or search for some certain modules based on your project and use the best one that you have the highest predictive performance. Yeah, I don't see any questions from Zoom too. If you guys okay, so that's for today. Thank you very much and enjoy your Valentine's Day. Yes, let me just share the link.